On September 15th, 2017, the Cassini spacecraft plunged into Saturn's atmosphere, ending its legendary 13-year mission. Scientists believed the data was already mined, the images archived, the story closed. But they were wrong, because buried within Cassini's final transmissions was something no one could see at the time, something that would only come to light years later when an advanced artificial intelligence was tasked with analyzing those final images. What it hypothesized has sparked debate among researchers. We're not talking about a blurry shape in the clouds or some anomaly brushed off by skeptics. We're exploring a possible structured pattern hypothesized across Cassini's last visuals, something that may suggest new questions about Saturn's mysteries. This is the hypothesis that could expand what we think we know about the solar system. Stay with us until the end, because what you're about to explore may inspire new scientific inquiries about our place in the cosmos. Cassini's mission was already a monumental achievement. It revealed the hexagonal storms of Saturn, the icy plumes of Enceladus, the methane lakes of Titan. As the spacecraft passed between Saturn and its rings, it captured high-resolution images of the planet's atmosphere, magnetic field, and ring structures with a clarity never seen before. Among these final transmissions were dozens of images that at the time appeared visually stunning, yet ordinary. Researchers praised them, archived them, and moved on. But there were anomalies, slight distortions, repeating geometric echoes. A few scientists raised eyebrows, but lacking context or tools, they chalked it up to technical noise. For years, these images sat untouched until curiosity and the advancement of computational processing resurrected them from obscurity. In 2025, a private research lab fed Cassini's final images into a state-of-the-art AI designed to detect subtle data patterns in astronomical imaging. The goal was simple: extract clearer data from noisy visuals. What the AI returned, however, was not just improved images. It hypothesized something buried within the visual layers, a possible repeated pattern, a symmetrical form, a signal potentially hiding in plain sight, invisible to the human eye. At first, researchers suspected algorithmic error until the pattern appeared again and again across separate image files, in different time frames, and at varying camera angles. The consistency was intriguing. The AI hadn't made an error. It had proposed something that warranted further study, something Cassini had captured as it fell into Saturn's arms, something worth investigating. As the team dug deeper, the pattern became even more intriguing. The AI began identifying numerical sequences within the pixel arrangements of the images. These weren't random. They included sequences resembling prime numbers, Fibonacci spirals, golden ratios, mathematical constants known across human science and often discussed in theoretical interstellar communication. In other words, this wasn't just a shape. It was a hypothesis of a message. This idea echoed the design of the Voyager Golden Record, where humanity tried to present its intelligence using universal mathematical concepts. But this time, the pattern wasn't being sent. It was being analyzed. The implication: Cassini may have captured data that, if verified, could suggest a new perspective, built into what we thought were natural, atmospheric visuals. It's as if something had anticipated we'd come looking and left us a trail in the only language we all speak: numbers. The more images the AI processed, the clearer the hypothesis became. In Cassini's final moments, it wasn't just photographing clouds and gas. It was recording a possible structured presence, like a lens distorting the space around it. One that did not behave like a natural object. Its symmetry was unusually precise, its motion consistent with patterns. And then came an intriguing finding. As Cassini descended lower, these patterns became more defined until suddenly, in one final frame, they vanished, as if the pattern had shifted or was obscured by atmospheric effects. Several experts now suggest that Cassini's final transmission could prompt new questions, not through direct contact like radio waves or flashing lights, but through geometry, presence, and data. Something worth exploring. Something we may only understand as our analytical tools advance. Saturn has always held a special place in the pantheon of cosmic mysteries. More than just its mesmerizing rings or swirling storms, it's a planet that defies expectations. Scientists have long known that Saturn emits more heat than it receives from the Sun, a phenomenon still under study, possibly due to internal processes like gravitational compression or helium rain. Combine that with the planet's unusual magnetic field, which doesn't align with its rotational axis like most planets, and you get a world that behaves like it's hiding scientific puzzles. Now, the hypothesized data from Cassini has cast new questions on those old mysteries. The mathematical sequences identified by the AI weren't just embedded in the visuals. They seem to correlate with specific latitudes on Saturn's surface, points that align with magnetic anomalies. These anomalies continue to puzzle scientists, raising questions about whether natural processes or undiscovered phenomena could explain these patterns. Regions where our instruments struggled. Regions where perhaps we haven't looked closely enough until now. As news of the hypothesized pattern spread, an intense debate erupted across the global scientific community. Was this all a strange coincidence? Pattern seeking gone too far? Or was the Cassini probe unknowingly capturing data that could challenge our assumptions? A data set waiting for us to analyze once our minds and machines evolved enough to explore it. Among those weighing in were leading physicists and AI researchers. Some argued that the consistent emergence of prime number sequences and golden ratio structures within the image data was statistically unlikely to occur by chance. Others pointed out that nature, especially in chaotic environments like Saturn's atmosphere, doesn't typically arrange itself with such clean symmetry unless driven by specific physical processes. And here's the twist. The AI didn't just identify patterns, it anticipated them. After analyzing the first few image clusters, it began predicting where new sequences BOS might appear in unprocessed data with notable accuracy. This suggested not randomness, but a pattern worth further scientific scrutiny. A signal potentially following rules, maybe even logic. There's one particular image that now stands at the center of the discussion. According to the mission's final logs, Cassini was set to capture a burst of rapid-fire images in its last moments before disintegration. Those final milliseconds should have produced a data stream of 12 distinct frames. But when the logs were reviewed after the analysis, only 11 images were fully readable. One was missing or corrupted. That's not a simple glitch. Engineers confirmed the sequence was transmitted in full. The missing frame wasn't lost in transit. It remains unreadable, possibly due to data corruption or transmission errors. When the AI reanalyzed the raw binary data, it located the packet, but the content was scrambled beyond current repair capabilities. Some researchers now hypothesize this 12th image may have contained additional data relevant to the pattern, a clearer form, a shape, perhaps even a structure. But without further technological advances, it remains an open question. Why this happened remains unclear unless natural data loss explains it. Since the Cassini hypothesis surfaced, a cautious curiosity has rippled through the astrophysics world. NASA has not issued an official statement on these hypothesized patterns, as they remain unverified. The research lab responsible for the analysis continues its work, focusing on rigorous validation. Their website remains active, sharing updates on ongoing research. Scientists are engaging in peer-reviewed studies to test these findings. What started as an exciting hypothesis remains under scientific scrutiny. Some call for more data, others for deeper analysis. But in the discussion, there's one message that's clear. Something was hypothesized, something was analyzed, and the scientific community is working to understand what Cassini's data might reveal about Saturn's mysteries. In the grand tapestry of space exploration, Cassini was supposed to be a final chapter, an elegant dive into Saturn's atmosphere, closing the book on one of NASA's most successful missions. But what we've explored may not be a closing chapter at all. It may be a new question, a scientific puzzle, or perhaps an invitation to look closer. The idea that an artificial intelligence trained years after Cassini's mission ended could hypothesize a hidden pattern embedded in its final transmissions is not just intriguing. It's a testament to advancing technology. It means the tools we use to explore the universe are evolving faster than our understanding of what's out there. And maybe, just maybe, the universe holds more questions than answers. Because if a machine can hypothesize what human eyes missed, if a spacecraft unknowingly recorded data that sparks new inquiries, then one question drives us forward. What do these patterns mean? And how can we deepen our understanding of the stars? If this hypothesis left you curious about space, time, and the mysteries beyond Earth, explore further with credible scientific sources. Engage with us if you believe this deserves more study, and share this discussion to inspire others to question what Cassini's data might hold. Because this isn't science fiction. This is the edge of discovery, and we've only just begun to explore what's waiting beyond the rings.